Good morning. I have already taken few classes on dynamics and few lectures were given from the chapter of kinematics. And the first chapter of kinematics was rectilinear motion. Only few problems were discussed. But I have noticed that few students are making mistakes. Mistakes means when acceleration or retardation are given in terms of time or velocities, etc. Means when acceleration or retardation, these are given as a variable, not as a constant. When these are given as variables, in that case also students are using the formula s is equal to ut plus half at square, v is equal to u plus at, v square is equal to u square plus 2at, etc. You have forgotten that while these equations were derived, one thing was assumed. What is that thing? That thing is that the acceleration or the retardation was assumed to be constant, not as a variable that was taken, not as a variable. Acceleration or retardation was taken as a constant. Whether he was using graphical method for the derivation of this formulae, or algebraic method, or using calculus. In all the cases, you try to notice carefully that acceleration or retardation was taken to be constant. So, these formulae, s is equal to ut plus half at square, v is equal to u plus at, v square is equal to u square plus 2at, or with negative signs when retardation is present. In those cases, these are applicable only when acceleration or retardation are constant, otherwise not. Okay. Acceleration was constant, that's why a straight line was used to represent the velocity. In the horizontal axis, time was taken. In the vertical axis, velocity was taken. And that straight line began from certain height. That height is initial velocity. And from the end of initial velocity, one line was drawn like this. Okay. And that line represents what? Velocity. Velocity which increases with time. Means acceleration was shown during the derivation of the formula s is equal to ut plus half at square. So acceleration was constant, that was only, that line was a straight line, otherwise it would be a curved line. So if in the given problem acceleration is given in terms of time or velocity or anything else, in that case you have to use from the very basic definition of velocity, then acceleration, etc. Like, say, for example, acceleration is given as a function of time, and the function is, say, it is t square minus 2t plus 3. T square minus 2t plus 3. This is what? Acceleration, a. So, in the left hand side, you have written a. In the right hand side, means after the equal sign, in the right hand side, you have written t square minus 2t plus 3. Now, this a, you should replace this a by dv dt, rate of change of velocity with respect to time, dv dt, and here acceleration is given as an explicit function of time. Okay, so now you write dv is equal to that right hand side quantity, that is t square minus 2t plus 3. Keep those terms within bracket and then into dt. Then integrate both sides. So in the left hand side you will get integration of dv, that is v, and in the right hand side you know integration of t square minus 2t plus 3 into dt. So you can integrate it easily. So after integration you will get a constant of integration. Okay, v as a function of time plus a constant of integration will be there, and using some condition. At this value of time, velocity was this much. One condition must be known to evaluate the value of the constant of integration c. So using that condition, you can calculate the value of c, then v is known explicitly. Okay. Now if any time is given, if you are asked, you tell me what will be the value of the velocity at time t is equal to 5 seconds, then in this equation you just put t is equal to 5 seconds. So you will get the corresponding result. Okay. And in the next step, if displacement is also required for the calculation, then you replace v by ds dt. S for displacement, or x also you can use, it is your choice. So v is equal to ds dt, then ds dt is equal to right hand side quantity, then ds equal to right hand side quantity into dt, then again integrate, then you will get s is equal to a function of time plus another constant of integration, say c1. Again some condition, again using some condition. At this value of time, displacement was this much. Using such condition, you can evaluate the value of C1 also. Then, now displacement is known in terms of time. So, your approach should be like this. Okay? When acceleration or retardation is given in terms of, is given as a function, means is given as a variable, then in that case, you have to use the very basic definition of velocity, very basic definition of acceleration. Means, what is the very basic definition? Basic definition of velocity is, it is equal to rate of change of displacement with respect to time. So, v is equal to ds dt. This is the very basic definition of velocity. Velocity is defined as rate of change of displacement with respect to time. This is applicable for all the cases. Not for special cases, for all the cases. And acceleration f is equal to rate of change of velocity with respect to time. Means dv dt. This is also applicable for all the cases, irrespective of any condition. Okay. Again, this acceleration f dv dt, this can also be written as dv dt is equal to dv ds multiplied by ds dt. You know this thing. Nothing new I am going to discuss here. F is equal to dv dt. So this is equal to dv by ds into dt. ds dt is what? ds by dt. This is nothing but velocity. So F is equal to v into dv ds. When there is a relation between displacement and velocity is given, relation between displacement and velocity is given, in that case you need to use this form of acceleration, means F is equal to v dv ds, v into dv by ds. This form of definition you need to use when relation between, mathematical relation between displacement and velocity is given. Okay. And this lecture was just to make you aware of the mistakes normally committed by many of the students. In all the cases, they use those formulae which are used for only constant acceleration or retardation. Okay? Always take care of this thing. Okay? Thank you.